All right, so before the break, we were going over chemical reactions. Okay, so what I'm going to do here, we're going to review the 5 types, okay, write some examples up there, and then do a little bit of review on that, review balancing, okay, and then move on to some more work on that stuff. So, whoa, I don't want the big marker. Okay, so our first reaction here, I'm just going to write this one. You guys tell me what kind it is. So let's say, okay, I'll have you guys write these ones down too as a review. So what kind of reaction is that? It's a simple decomposition reaction, right? The compound is breaking down or decomposing into its base elements there, okay? So we would have there as a decomp. Okay, is it balanced? Definitely not balanced. Okay, and this is also one of the tricky ones where if we go by our rule of balance the biggest number first, that this might not work. Okay, we can try it, but actually, no, it will work. So let's balance the biggest number first. So I got a 3 here and a 2 over there for my hydrogens. How do I make that balance? What do I need to find about 2 and 3? Need to have the same amount on both sides of the reaction. On one side I have 3, on the other side I have 2. Okay? What's a number I can use that they would both go into? 6. I need the lowest common multiple in order to make this balance. Okay? Since the lowest common multiple is 6, I'm going to need to multiply this hydrogen by 3. 3 times 2 is 6. Okay, and this hydrogen here by 2. 2 times 3 is 6. Okay, now the hydrogens are balanced, and so are the nitrogens, because this 2 also applies to that nitrogen, and there are 2 nitrogens on this side, and now the reaction is balanced. Is that ringing a bell? Okay, let's see how we do with this one. Okay, I'll give you a minute, write down the reaction type and balance it. Okay, which reaction type are we looking at, number 2? Single replacement. We have an ionic compound reacting with an element, producing a different ionic compound and a different element. Okay, so single replacement for that one. All right, is it balanced? Not right now, because there's how many nitrates on the reactant side? 2. How many over here? Just 1. Okay, so I need to put a 2 in front of this. Now my nitrates are balanced, so that's good. Okay, but when I put that 2 there, it also gives me 2 lithium. Okay, so I need to put a 2 in front of this, and now it looks like everything is balanced. There's 1 calcium on each side, 2 nitrates on each side, 2 lithium on each side. Okay, now it's balanced. Okay, questions on the second one? Okay, so what kind of reaction are we looking at there? Synthesis. Two elements are combining to form a single compound. Okay, synthesis reaction. Okay, is it balanced? Okay, right now oxygen is out of balance, right? Nitrogen's balanced, there's 2 on each side, but oxygen is not. Okay, so I've got to balance the oxygen. There's a 2 on this side, there's only 1 over here, so what needs to go here? A 2. Okay, but that gives me 4 nitrogens, so a 2 there will balance the rest of the reaction. Okay. Questions on the third one? Okay, what kind of reaction are we looking at there? Double replacement. 2 ionic compounds reacting to form 2 different ionic compounds. Or in other words, the metals just switch places with each other. Okay, or switch partners with each other. All right. Is it currently balanced? No. Okay. So what's currently out of balance is chlorine. Okay, everything else actually, oh no, sorry, the sodium is also out of balance. Okay, so if I have 2 chlorine on this side, what do I need to put in front of this? A 2. Well, that fixed everything. It does, because there's 2 sodium over there. Okay, so now there's 2 sodium and 2 chlorine on both sides, 1 iron, 1 carbonate, 1 carbonate. Now it's balanced. Okay, all right, last one. Okay, what kind of reaction are we looking at there? Combustion reaction. Okay, we got a hydrocarbon, carbon and hydrogen reacting with oxygen. CO2 and water are always the products of a combustion reaction. Now, are there special rules to follow for balancing these? Okay, and the 2 rules are, I balance in alphabetical order, and the rule of 2. If I have an even number of carbons, I start my balancing with a 2. And I need both rules for this one. So I'm going to start with a 2 because 6 is an even number, and then I'm going to balance in alphabetical order. 2 times 6 is 12. Now I have 12 carbons on that side. Okay, 2 times 14 is 28 hydrogens. 14 times 2 is 28 hydrogens. Okay, now I've got to look at the oxygens. 12 times 2 is 24 oxygens, plus another 14 oxygens there, okay, is going to give me a total of 38 oxygens. 19 times 2 is 38. Okay, those are the trickiest ones for balance. All right, ringing a bell. Okay, so here's the plan, guys. We're going to work on reactions today and tomorrow. Okay, tomorrow we're probably going to start looking at predicting the products of a reaction. Okay, your lab reports, don't forget, okay, are due on Wednesday. Okay, I've had a few people come in and have them looked over. Okay, so far so good on those. Okay, if you want to take advantage of that, make sure you come and see me. Okay, during my help times. Okay, so for today, that's the first half of lunch and obviously scheduled help right before that. Okay, and after school as well. If you want to come in then, okay, you can come and see me at those times. I forget where I was. Oh, lab. Okay, on Wednesday, we're gonna have the Chromebooks. We're gonna spend a little bit of time on reactions and start the pre-lab stuff for our reactions lab, which we're gonna do on Thursday. Okay, so that stuff is all coming up this week, okay, for you, and then probably Monday of next week, we will do our assignment on chemical reactions, Monday or Tuesday, depending on kind of how we're doing. This week's quizzes will both be on chemical reactions. Okay, and incidentally, it'll post at 3:30 as always. Okay. All right, now, when you're given the full reaction like this, is that easier than when I give it to you in words? Okay. On that note, here's 3 in words. I want them written out in formula form, identify the type, and balance. Okay, let's have a look at the first one here. So we got iodine, react with magnesium to form magnesium iodide. Was anyone else having trouble with that one? Did I disobey one of Dalton's rules? Yeah, definitely. Made a new compound, sorry, new element somehow. Should be iodide. Okay, well, let's look over that one because that had a mistake in it. So what do I need to remember about iodine when I write it in this reaction? Right, it's special, comes as a 2. Okay, that's one of the things that's tricky about writing them out in words or writing them out in formulas from words. Okay, reacts with magnesium, which is not special. Okay, and it makes magnesium iodide, which would be MgI2. All right, is it already balanced? 2 iodines on each side, 1 magnesium on each side, looks good to me. What kind of reaction is it? Synthesis. Okay, how many people have done the second one? Okay. So our second one here, we got copper 2 nitrate. So when I'm writing out the formulas here, that Roman numeral tells me it's the copper with the 2+ charge. Okay, that means I'm going to need brackets around the nitrate and a 2 outside because it's a -1. Okay, and it's reacting with sodium. Okay, to produce sodium nitrate. Okay, that's a +1. That's a -1, so that compound is fine the way I have it written. And copper. Okay. What kind of reaction is that? Yeah, single replacement. Okay, so I got a single replacement reaction and it needs a little bit of work because it's not balanced. Okay, I have 2 nitrates on the reactant side, but I only have 1 on the product side. So what number do I need to put here? 2. Okay, when I do that, not only does it give me 2 nitrates, it also gives me 2 sodium. So a 2 there will balance the sodiums, and now the rest of the reaction is balanced. Okay, how many people have done the third one? Okay, I'm going to give you like 1 more minute, and then we'll go over the third one. Okay, let's have a look at the third one here. All right, so I got silver nitrate. Okay, so that's going to be Ag. That's a +1. Nitrate is a -1, so that compound is fine the way I have it written there. Okay, is reacting with lead 2 phosphide, so Pb with the 2+ charge. Phosphide, which is a -3, so we're going to have Pb3P2. Okay, and so that is going to give us on this side silver phosphide, Ag +1, okay, phosphorus -3, so Ag3P, okay, plus lead 2 nitrate, so PbNO3 2. All right, what kind of reaction is that? Double replacement, yep. Okay, because we've got 2 ionic compounds reacting to form 2 different ionic compounds, so double replacement. All right, biggest number here is 3, and it's with the lead. Okay, so we can start with that and see how it goes. Okay, so I've got 3 lead on this side, right? So I need to put a 3 over here. Okay, now my lead are balanced. But in doing that, I now have how many nitrate? 6. All right, so I've got to go back over here and put a 6 in front of silver nitrate. Now my nitrates are balanced. But now I have how many silver? 6. All right, so I got to go over here. What needs to go in front of this to make 6? A 2. Does that make my phosphorus balance? It does. Okay, and now I'm finished. Now everything is balanced. Okay, everybody all right with that one? So that's how a more complex balancing equation would work. Start with the biggest, and you're just going to bounce back and forth between products and reactants until you have them all balanced. Every time you put in a new number, go back to the reactant side or the other side if you're on the product side. Okay, go back to the other side and fix the one you just put out of balance, and then fix the next one, and then by the end you should have the last one balance itself with whatever you've done. Okay, but that's about as tricky as they get. Is this ringing a bell? This is what we left off with, okay, on Friday before the break, was having word reactions, okay, writing them out, and balance. Okay, so let's have you guys continue on with those 2 there. Okay, see how we do with those 2. All right, so on number 4, I've got disulfur trinitride. So that would be S2N3. Okay, and it breaks down into sulfur and nitrogen. What do I have to remember about both of those? They're both special, and sulfur is especially special. Comes as an 8. Yeah. Okay, so I've got S8 and N2. All right, sorry. So now I've got to balance this thing. Biggest number is 8, so I'm going to start with that. Okay, I've got 8 sulfur in the products, but only 2 over here, so what do I need to put here? 4. 4 times 2 is 8. Okay, 4 times 3 is 12. Okay, so a 6 here should give me the 12 that I need, and then that would be balanced. How many people have the combustion reactions then? Okay, let's have a look at the combustion reaction then. Okay, so it gives me the material because we don't know the prefixes above 10. So C9H20, okay, which is nonane, okay, plus oxygen gives CO2 and water. All right. Do I need the rule of 2? Nope. Okay, so I'm just going to start balancing alphabetically because 9 is an odd number. So 9 carbons, 20. That is terrible. Sorry, guys. That makes it look like it's H2O. It's supposed to be H20. Okay, 20 hydrogens, so 10 times 2, okay, will give me 20. 9 times 2 is 18, plus another 10 is 28. 14 times 2 should give me 28, and that would be balanced. Okay. All right, how are we feeling about that? Is it ringing a bell? Okay, I know probably none of you looked at this stuff over the holiday, and that's why we're reviewing it today. Okay, why we're going to spend some time on it. But I want to see if this is something you guys can figure out. Let's say I give you something that looks like this. Let's say I only give you that much of a chemical reaction. Can you identify what type it is from just the reactants? It's a single replacement reaction. Okay, I can identify all 5 of our reaction types from only the reactants. They all start differently. Okay, so being able to identify a reaction type given only half of the reaction is a skill you're going to need, okay, going forward. So it's a single replacement reaction. So now what I've got to ask myself is, what happens in a single replacement reaction? Well, in a single replacement reaction, the element that's by itself is going to replace the part of the ionic compound it's reacting with, okay, that is similar to it. So calcium is a metal. What part of this compound is the metal? The lithium. All right, so according to what happens in a single replacement reaction, calcium and lithium are going to switch places. All right, so who does that mean is going to be with calcium on this side? Oxygen. Who's alone? Lithium. Okay, did you just predict the products of that reaction? Okay, that's how you predict the products of a reaction, right? You identify the type, and then you use the pattern of that reaction to figure out what would be on the other side. Yeah. Okay, now that reaction is not balanced right now. Okay, we would need to put a 2 here in order to balance that, but that's it. Okay, and predicting single replacement reactions are actually some of the hardest ones to do. Right? Just so you see what it looks like. I'm not going to expect you to be able to do that just yet, okay? But we'll probably start looking at that a bit tomorrow. Okay. All right. So here's just some balancing work, okay, for you, and reaction types as well. So this one is in your digital workbook. Okay? I can't remember what page it's on, but I'll bring it up. Okay. I would like you guys to get going on that one. Like I said, I'll bring it up here from the digital workbook. Yes, it's me. Okay, so remember that that is in your course materials. Okay, it's here, worksheet packages and other materials. Okay, and it's down here. You want the chemistry worksheet package. And this particular worksheet. Okay, is on page 9. Okay, so I'll put it up there. You guys can see a bit more of it on this screen, but it's page 9 in your digital workbook. All right, and what I would like you to do, okay, is balance those reactions, and after you get past G, okay, you're identifying the types as well. All right, and we'll go over a few of those here in a little bit. Okay, let's say, actually, you know what, let's say, I'm just gonna put some ones on here. I don't want you to do them all. Okay, let's do this instead. Let's have you guys do just B, E, G, K, and L. Okay, for right now, just to kind of practice our balancing and identifying. Okay, that shouldn't take you very long, and then we'll move back to doing some word reactions after that. Okay, so let's have a look at these ones here. So for B, I got to start with the biggest number for my balancing, but 2 of them have a 2 in front of them. Right? If I start with mercury, though, I can already see that I'll have to erase whatever I write because oxygen will be out of balance. Okay, so I'm going to start with oxygen. It's a 2 on this side. What needs to go here? A 2. Okay, when I put that 2 there, it gives me 4 mercury. So I'm going to need to put a 4 there, okay, and that's a 1. Just as a note here, if you ever get balancing questions that are strictly fill in the blank, put a 1 in the blank if it's a 1. Don't leave it blank. Because if you leave it blank, I have to assume you didn't know how to do it because it's not filled in. Okay, that's the difference between putting a 1 there and leaving it blank. If you're writing out the whole reaction, I don't expect you write 1s. But if it's fill in the blank, fill in the blanks. Okay, everybody with me there? All right. For E, okay, what should I probably start with? Oxygen's the biggest number, 3. Okay, I've got 3 oxygen in the reactants. I only have 2 on that side. What's the lowest common multiple? 6. All right, so on this side then I'm going to put a 2 here and I'm going to put a 3 here. Putting that 2 there gives me how many aluminum? 4. Okay, so 2, 4, 3 for E. Okay, and then for G, looking at my stuff here, this one here, what would I change if I wanted to balance this one more quickly? I would change one thing about how this reaction is written. Is it okay if I make that change? Still water, right? But now it's easier to see where the OH and the H come from. Okay, I know that there's 2 OHs on this side, but there's only 1 OH over here. So I'm going to put a 2 there. Okay, that's going to give me 2 hydrogens. So I'm going to put a 2 here. That's going to make my chlorines work. Those are 1s. It's a tricky one, and it's tricky because they didn't do that thing I told you about before the break. If you have a double replacement reaction and water's involved, write water is HOH. Okay. All right, looking at K. What kind of reaction are we looking at there? I got an ionic compound reacting with an ionic compound, making different ionic compounds. Double replacement. Okay, now looking at that mess there, biggest number is 3, and it's on both chlorine and sulfur. Which one should I balance first? The one with the biggest charge, because it'll have a bigger effect on the reaction. Sulfur is the bigger charge. 3 sulfur on this side, only 1 on this side, so I'm going to put a 3 there. That 3 gives me 6 hydrogens, so I'm going to go over here and make sure I have 6 hydrogens. When I do that, it gives me 6 chlorines, so I got to go back over here and make sure I have 6 chlorines, and when I do that, it gives me the 2 arsenic I'm supposed to have right there. 2, 3, 1, 6 on that one. Tricky balance. For sure. Okay. And for L, what kind of reaction am I looking at there? Single replacement. Yeah, it's an ionic compound, reacts with an element. Okay, so biggest number is 3. It's on oxygen, so I'll balance it first. I'll put a 3 here. That gives me 6 hydrogens. A 3 here will balance my hydrogens. And a 2 there should balance my irons. A 1 in front of that, and I should be done. Okay, so balancing gets tricky, but if you follow the rules we've established, you're going to be okay. Right? Okay. Give you about a 5-minute break here, guys. I don't want to do those yet. Okay, so for number 5, we've got nitrogen trihydride. That'd be NH3. Okay, and it's reacting with oxygen. What do I have to remember about oxygen? It's comes as a pair. It's one of our special elements. And guys, it is so crucial that you know which ones are special, because if you don't, and you write that as O, you don't get the reaction right, you don't get the balancing right, okay? If it's a 3-mark question, you're gonna be lucky to get 1 out of 3, okay? You gotta remember which ones are special. All right, so that is going to produce nitrogen, which is another one you have to remember is special, and dihydrogen monoxide, otherwise known as water. Okay, so H2O. So that's what that reaction should look like. Okay, it is a, well, it's not really a replacement. It's a replacement reaction, but it's not the kind that we've gone over. Okay, so we need to balance this thing. Right now, it looks like probably hydrogen would be our most problematic one. It's the biggest number. Okay, 3 on this side, 2 on that side. So I'm going to try and balance that by making them each a 6. That isn't going to work. Okay, because when I put this 3 here, it's not going to work with my oxygens. So what I will do instead is I will start with the nitrogens. Okay, I'm going to put a 2 here. Oh no, that already did that. Okay, let's look at doubling up here. Let's try making these a 12 on each side and see what happens with that. So let's put a 4 in front of this. Okay, and then a 6 in front of this, and then a 3 in front of this one, and yep, that'll work. Okay, so that's a tricky balance. Okay, if you try balancing that one using the rules that we went over, it doesn't work the first time. It probably doesn't work the second time. Okay, here's a good trick for you. If you've tried using the biggest one first and it didn't work, try doubling the number you used. Okay, if you double that first number you used, that'll work. That's all I did here. Instead of putting a 3 in front of that and making it 6 on both sides, I made hydrogen 12 on both sides. Okay, just make it bigger until it works. All right, questions on number 5, because it's a tricky one. Okay, number 6, carbon and oxygen. So carbon, just C, oxygen, 2, okay, O2, it's a special one, produces carbon dioxide. Synthesis reaction that is already balanced. That's pretty straightforward. Okay. For number 7, we got calcium oxide. So Ca with O, that's a -2, that's a +2, so that one's okay. Reacts with magnesium chloride. This is a 2+, this is a 1-, so we're looking at MgCl2. Okay, is going to produce magnesium oxide, MgO, -2, +2, so that one's good. And calcium chloride. Okay, that's a +2, that's a -1. Okay. So now we've got all the compounds correct, and it's balanced, and it's a double replacement reaction. Okay. Questions on 7? Okay. How many people have done 8? Okay. So hydrogen iodide, that would be Hi. That's an ionic compound, so +1 and -1. Okay. And oxygen, you have to remember it's special, it's a 2. Okay. Produces iodine, also special, and water. Okay, so balancing wise here, hydrogen's a 2, iodine's a 2, oxygen's a 2. Oxygen's got the bigger charge, so I'm going to go with that first. Okay, I'm going to put a 2 in front of this to balance my oxygens. That's going to give me 4 hydrogens. I'm going to go back over here and make 4 hydrogens. That's going to give me 4 iodines. Putting a 2 there will give me 4 iodines, and then the reaction is balanced. So that one worked exactly as we would have predicted it would work, okay, given our balancing rules. How many people have done number 9? Okay. So for number 9 here, okay, we got magnesium, not special, reacts with nitrogen, special, to produce magnesium nitride, Mg with N, but this is a +2, this is a -3, so Mg3N2. Nitrogen's already balanced, my biggest number is 3, now my 3 is balanced. Okay, synthesis reaction for that one. Okay, how are we feeling about these? We're ringing a bell now? Okay, I'm going to challenge you with another one. Let's go with this. Okay, potassium reacts with nitrogen. Predict the products. Write the whole reaction, reactants and products. So if I'm writing out the reactants here, okay, potassium is K. It's reacting with nitrogen. Is nitrogen special? It is, and I have to remember that. Okay, what kind of reaction is that? It's a synthesis reaction. Two elements are reacting with each other. Okay, so that means that they're going to go together on this side to form a single compound. Since it's going to be an ionic compound, metal and a non-metal, I can figure out how many of each there should be. K3N by doing the drop and swap. Okay, now when I want to balance this reaction, I should actually not go with the biggest number, but start with nitrogen instead. Okay, put a 2 here to balance my nitrogens and a 6 there to balance my potassiums. Okay, tomorrow, after your quiz, which is on reactions, you will get 3 reactions that are, I write the formulas out and you've got to write it in words and balance and identify the type. The other 3 are, I give it to you in words, you've got to write it out in formula form, identify the type and balance. Okay, and there's one at the end that won't be for marks. That is a prediction question. Your practice quiz is set up exactly the same. It'll post at 3:20 today with the solutions video. So I suggest you try that and have a look over that. Okay? And come and see me if you want your lab report reviewed before you submit it. 8:30 a.m. on Wednesday for that.